Hey everybody, in this video we are beginning lesson 3, algebraic techniques for finding limits. There are a few rules in this chart and I am going to kind of add 3, but really just one more rule to the list for now because it does come up quite a bit in the examples that I will have us working on. But these are going to seem a little bit self-explanatory or silly at first, but in action you understand why these rules essentially exist. Okay, so what we'll have is rule number 1, limit of a constant. Basically the limit as x approaches essentially any numerical value. So when you take the limit as x approaches a number of a constant, or even if we're approaching infinity, to be honest, the answer will be that constant, because it's really visually we're talking about a horizontal line is our function, and basically the y value, no matter what x value you're approaching, the y value is always going to be at whatever that constant value is, so that will always be your limit. Okay, the limit of a sum or a difference is the limit of each piece of that sum or difference. So the first part, second part, whether you're talking about a polynomial and you're talking about the quadratic term plus the linear term plus the constant term, yada yada. Limit of a product, if we have two functions sort of being multiplied by each other, and that is the same idea. Product is a quotient, multiplying by the reciprocal essentially is a quotient, right? But if you do indeed have a denominator, disclaimer, our denominator can't equal 0. So again, to find the limit of a product or a quotient, a sum or a difference, you're essentially just finding the limit of each piece individually, and then either adding, subtracting, multiplying, or dividing your answer. So f of x, I find the limit of it over there. Here's g of x. I'm going to find the whole limit over there, and then I'm going to add those answers together, right? Similar to that in the quotient or the product, f of x or f of x. If I'm finding the limit and f of x is a component there, I'll find the limit of f of x, put that on the side. Then I will find the limit of g of x, put that guy on the side. And then I will either multiply or divide my results based on whatever the original question is or was. So let's do a few of these examples over here just to kind of warm it up, and then I will show you the extra rule. Okay, the limit as x approaches any constant c of 7. Well, 7 or any value c. 7 is a constant. Boom, the answer is 7. Done. Next, after that, number 2 to the right. The limit as x approaches c of x. Well, you just can do direct sub. X is a continuous polynomial. It's a linear parent function. It's the identity function. So if I plug in the value c, I get, in this case, c. Next, number 3 on the left. The limit as x approaches 3. It's another linear. Now, if I'm looking at it in the way that they want us to look at it, it's the limit as x approaches 3 of x plus the limit as x approaches 3 of 4. But no one, guys, we're not going to write it like this. It's a bit crazy, So for this part, the answer, plug in 3, is 3. Here, it's a constant. The answer is 4. My final answer is 3 plus 4. So the answer is 7. But really, I can just do direct sub in my head. Essentially 3 plus 4. And the answer is 7. If you're manipulating your functions that you're using on the limit, in the limit, you have to write limit as x approaches whatever every step of the way. And then when you actually take the limit is when you could drop writing that. So here again, they would more or less expect you to find the limit of this guy, the limit of this guy, and then subtract your answers. But we are normal people, so we're going to just get our answer 2 minus 5, and that final answer, negative 3. The limit of this is a product, essentially negative 5 times x, if we think of it like that. So the one part is a constant, so that answer is just going to be negative 5, right? Then the limit of the second part, the limit as x approaches 3 of x, well, that's just 3. And what do? I multiply my answers and I get negative 15. After that, I have a quotient. Limit as x approaches 6 of x, we'll plug in 6, direct sub, that's 6. Limit as x approaches 6 of the 2 on bottom. Well, that's a 2 still on bottom. It's a constant. And then I take my answers, stack them back up into a fraction, and simplify 3. Over here, Number 7, same idea. I have 5 and I have x squared. So the x squared kind of introduces a bit of a thing, but I'll save it for the next rule. So the first limit is still 5 times x squared. Well, the limit of x squared is 3 squared, which is 9, and 5 times 9 is final answer 45. And our last example here, same exact idea. Essentially, you're going to find the limit of each part, right? So I'm going to find the limit of each of these 4 parts. Within each of those, I even have like a product, and I actually have like x being raised to a power, so one could argue it's f of g of x, which I will show you in a moment. But for argument's sake, we'll just focus on more or less direct sub. 2 to the 4th is 16. 3 times 16 is 48. Minus 5 times x cubed. 2 cubed is 8. 5 times 8 is 40. 48 minus 40 is 8. Plus 2 squared is 4. Times 2 is 8. So adding 8. So where was I? I was at 8. 8 plus 8 is 16. And minus 6. Final answer is 10. So there we go. Now, what are these extra rules before I move on to the different techniques, which is like the money video, but different limit. Okay. A few extra limit laws or rules, again, depending what textbook you're using. So some call it laws, some call it rules. You know, I don't make the rules or the laws. So here, the limit as x approaches c of a function f of x that is being essentially raised to a power. What we're going to do is find the limit of the inside part and then raise the power after the fact. Okay, I'm going to find the limit of the inner part and then raise the power after. So what could that possibly mean? Well, if I have something like the limit as x approaches 2 of x plus 3. So if it was just that, right? Limit as x approaches 2 of x plus 3. We saw something like that just a minute ago. That answer you could just do direct sub. 2 plus 3, I would get 5. But let's say it's raised to the 4th power. Well, then I take my answer and I raise my answer to the 4th power. So this rule is saying that essentially what we do is we find the limit as x approaches 2 of x plus 3. You get that answer and raise your answer to the 4th power. That's really what it's saying. Again, here we just said here we would get 2 plus 3, so we get 5 to the 4, and 5 to the 4, 625 is your answer. So that's how they kind of show the rule. Similarly, right? Similarly, come back here. Okay. On this thing. Here. This one is this exact same rule. It's just really visually showing it with a radical, but we know 1/2 power is the same as a radical. So like if in the first rule right here, right, in this situation, it was all raised to the 1/2 power, right? That's the same as a radical. So it's literally the same rule in action. And really, this doesn't just apply to raising to a power or a simple square root. This is really any composition of functions, because that's what we're really looking at. So when you find the limit of a composition of functions, f of g of x, you really find the limit of the inside function, and then you find the f of that. In other words, the limit as x approaches c of g, if the limit of the inside is m, okay? If the limit of the inner part is m, then the limit of the composition is the f of m. And that's really what we just did. So it's the 4th power of that. It's the square root of that. So that's what this rule says. I will point this out in other examples. All right. I know it might seem like a little like, what are we blabbing about? Why are these things? But we need rules, you know, we need structure and guidance when we're doing problems like this. So I hope that you manage to jot these down somewhere in your notebook. That would be great. And I hope you kind of get the gist of what's going on. I know it looks like a lot of hieroglyphics and gibberish sometimes. So I hope that this was helpful. If you think so, go ahead, give us a thumbs up. If you feel like you wasted your life, go ahead, give me a thumbs down. I won't cry. Questions, comments, concerns, feedback, or requests can go in the comment section, and I will do my best to get back to you. And then check the playlist for other videos on this topic, or the playlist or the description box below. I don't even know what I'm saying anymore. All right. Oh, I didn't put my thumbs up. Girls on the screen. Hold on. The happy girls. There they go. All right. So there we go. So hopefully you give a thumbs up. That's it for now. Adios.